Okay, so hopefully by now you've watched the Khan Academy videos that I posted for you on how to determine the volume of a solid generated by revolving an equation around the x-axis. The method that you were watching is called the disk method because you're essentially getting little flat coin-shaped disks every time you revolve your function around the x-axis. So this is called solids of revolution. And this is section 7.2 in your textbook if you want to take a look. And it's very important that you pay attention to which axis you are rotating your function around. For the disk method, which is what we're talking about today, you can have either a horizontal or vertical axis of rotation. And today we are just going to focus on practicing getting our feet wet with a horizontal axis of rotation. So the volume of the solid generated by rotating a function around a horizontal, that's how you spell it, horizontal axis of rotation is going to be found with the formula V equals pi times the integral from A to B of r of x squared dx. Okay? And r of x is the function that describes the radius of the disk. So what we're talking about here is if we take and we have a function, let's say our function is a quarter of a circle. Okay, so our function here, f of x, and we're going from A to B, so we're actually going to go just from the y-axis to this point. What we're thinking about is what happens when we take a rectangle that has some height, okay, on our, and what we're going to do is we are going to rotate this around the x-axis. And when we do that, what we're going to see is we end up at some point down here, and we've got the rest of our rectangle coming down here, and this point is going to come around and it's going to do the same thing, and this is how we are forming that disk shape that we were talking about in the Khan Academy video. Okay, so I'm not very good at drawing like he is, but you kind of get the idea. that as I'm rotating this around, I'm going to sweep out an area that's actually curved in nature, and that this height of my rectangle is the radius of each individual disk. So in general, the height of the function, okay, is going to be the r of x value. And if you're rotating around the x-axis, then in this case, the radius function is just f of x. I'm writing it as the radius function because when we start rotating around things that are not necessarily the x-axis, this r of x function is going to change. It's still going to have something to do with f of x, but it's not going to be equal to f of x. So they're equal to each other in this case where we're rotating around the x-axis. Now, in general, what I like to do when I'm doing this is I'll put a little circle over here and I'll show where I'm rotating around, so I make sure that I know where I'm rotating and that I'm understanding where my r of x function is coming from. Again, if you have a question about where this formula comes from, you can watch the video from Khan Academy. It has much better drawings to explain where that formula is coming from. Okay, so what I want to do is to just go ahead and work an example so that we can see how we apply this formula to finding the volume of a function that we're given. Okay, so the question we want to answer is to find the volume of a solid generated by rotating our function f of x equals the square root of x around the x-axis. So the first thing we're going to do is I'm going to go ahead and graph this. I know it looks like a complicated function, but we're only going from 0 to pi. So if we just graph our important points into this function, we can go ahead and get this graph relatively easily. What do we know about the sign of x at 0? Well, that's 0, and the square root of 0 is still 0, so that's no problem. Okay. What is the sign of pi over 2? The sign of pi over 2 is 1, and the square root of 1 is 1. Okay. The sign of pi is 0, and the square root of 0 is still 0, so you can see that the square root of the sign of x, its graph is exactly the same as the graph for sine of x. It's just going to give us an easier integral, which is what we're looking for here. Okay, we're going to go from 0 to pi. That's why I put that on my graph here. And I always like to draw in a random rectangle. So I'm going to pick a point on my graph and draw in a rectangle from there so I can imagine what the disk is going to look like as it's rotating around this axis. Okay, so you can see that when we do that, it makes it a lot easier for us to visualize that at this point, this is the radius of our disk, and so we can go ahead and write down our function. In our formula, we have a pi out here. We go integral from a to b. Okay, so our a is 0, our b happens to be pi. These have nothing to do with each other. This is part of the formula. This is actually part of the question. My function for the radius is the actual function given in the question. And I'm going to square it, dx, because we're in terms of rotating around the x-axis. So the width of our rectangle is dx. So if we go ahead and simplify this, this is pi integral 0 to pi of sine x, because square root and squared cancel each other out. Like I said, it's a pretty simple integral. So then we've got pi times our answer, which is negative cosine x from 0 to pi. Okay, and if we go ahead and fill that in, again, I'm going to wait and multiply the pi at the end. So I've got pi times what I get from this. This is negative cosine pi minus cosine 0. So what we have here, pi times cosine pi is negative 1 minus cosine 0, which is negative 1. So this is 1 plus 1. So this is 2 pi. So what that tells us is that the volume of this entire red shape, if I were to rotate it around the x-axis and find the solid shape that we're rotating around this axis, it's kind of make like, I don't know, like an egg shape, that the volume of that egg shape is 2 pi. Okay? Hope that helps. Let me know if you need any more explanation or help with the practice problems.